OSPF has a number of different network types. Point-to-point is what we get on HDLC, PPP, or frame relay sub-interfaces of type point-to-point. We don't need a DR here because a DR is about having a central point of contact. You don't need a central point of contact if there are only two contacts, because if you communicate out a serial interface, it can only go one place. We see the timer here that has to match. So it also makes sense that you would have to match the network types accordingly as well, because if you have a mismatch, that could control a mismatch of your timers as well. Do you get dynamic neighbor discovery? No. Only one of these doesn't have it. On point-to-point, you can only have two routers in a subnet. That makes sense. On broadcast, the traditional way that we run, you can see the line items on this row. This isn't that important. Non-broadcast, this modality demands a DR. This is the default in frame relay multi-point sub-interfaces as well as a major interface. So if you don't configure on a sub-interface, this is what you get, which may mean you want to manually specify your neighbors with the neighbor command. And you want to control the DR and make sure that that is on the hub. My favorite way of running OSPF in a multi-point frame relay environment is this one. Point to multi-point. You do this on all your routers and then you just move on because it solves all of your issues. It solves all of your issues. What it does is it fakes OSPF out and treats things like point-to-point so it simplifies the network from the perspective of OSPF. Point to multi-point non-broadcast is pretty unusual. This is only to be used in a media type that doesn't support point to multi-point, and that's none of the ones that we've listed. This modality exists for media types that are no longer taught. But if you did happen to do this, you would also have to manually configure your neighbors. Very unusual. And finally, loopback. Now, this wouldn't be something we would do for network connectivity, but something to be mindful of is if you do advertise a loopback, there's no DR there. So we're not going to try to find something else to communicate with. And I think that that should make sense. My favorite way of configuring OSPF in a multi-point environment is point to multi-point. This solves all of our woes. Very straightforward. We just do a single command on all of our routers. Let's do this. If we were to configure this modality, and right now I'm in multi-point. Actually, I'm in multi-point, but it's network type of non-broadcast. So we'll do a show IP OSPF interface. And on our frame relay configuration, we have network type non-broadcast. So what I'm going to do is this. I'm going to go into our interfaces. I'm going to say IP OSPF network, point to multi-point. I'm going to do that on all of my routers because we really want to share the network type. You might be able to form adjacencies, but you don't want to leave this up to chances. So I'll just paste that in there. So I'm configuring R4, 5, and 6, a hub and spoke environment. Classic example of where to use this. Is that the right interface? Yes, it is. Paste that in there. We'll verify our neighbors. We are getting a neighborship across this connection. That's looking good. Let's look at it from the perspective of R4. You can see that we're getting neighborships formed across here, and we are not getting designated router operation. Does that agree with what we are saying? Point to multi-point. We automatically form OSPF treats loopback interfaces a little differently, and you need to be mindful of how OSPF works here. Particularly this thing right here. It says only one router is allowed in the subnet of a loopback interface as advertised. Okay, no big deal, right? What does that really mean to us? Well, let's take a closer look. So let's create a new loopback interface. Do a show IP interface brief. And we'll create one int loop 0. No, it's already there. Int loop 1. Let's say that is 172.16.30 or .47 with a 24-bit mask. It says bad mask. It's really not a bad mask. It's a bad IP address. I'm going to advertise that. So I'm going to say network 172.16.47.6 in area 567. Okay, so I have a new network now. Let's look at it from the perspective of router 1. Do a show IP route OSPF, and I want to find that 47 network, and I want you to see, wait a minute. It says /32. That's not the mask that I configured. That is not the mask that I configured. And it had nothing to do with my wildcard mask. It had everything to do with the fact that the network type is loopback. I'll do a show IP OSPF network loopback 1, interface loopback 1. So we see the network type is loopback. Let's change it to point-to-point. And yes, you can do this. And yes, actually, people do this. IP OSPF interface, IP OSPF network. Let's see our options for this one. I'm in the wrong mode, so sorry about that. We'll do IP OSPF network type. And we'll say point-to-point. And guess what? Now that interface or that network is going to be advertised respecting the mask that we have. So this was the before picture. I'll rerun this output and we'll get the after. We are now respecting the mask. So if you were ever trying to advertise, let's say in a laboratory environment, a loopback interface and the network for it, and it's just tacking on /32, change the network type to point-to-point. And what you're really doing is you're giving it the ability to have more than one router in the subnet.